Hi all, this is Santiago Garay and welcome to SkinDesigner's tutorial number 3. In this tutorial we are looking at panel functions. There's a couple of scripts that will deal with panel functions in a couple different ways. The first one will focus on generating a facade with variable panel heights. Based on a panel that we designed, and then creating different versions of that panel that it has variable windows sizes and window heights. The second one is creating a screen in one side of the building that is using dynamic components, and I'll show you a little bit how that looks like. It's dynamic components are the most complex part of SkinDesigner, and I developed this one component that is inspired on the Al Bahar Towers in Abu Dhabi, but showing also how you can articulate its parameters and in this case the rotation of those elements of the panel to create a range also of variable openings and sun shading kind of configurations. Okay, so with that we're gonna get started. Start with that facade first with the variable window sizes. So I'll turn on first looking at the panel. As always, the first step, we have a simple panel that it has a window, and basically the main distinctive part of this is having this custom geometry element, which is a simple solid, and I linked here, and you see the shape of that solid. It's a triangular shape. It's 1 foot by 1 foot by 1 foot everywhere, every dimension, which allows us to scale this up or down, and in this case is matching with the x axis, the 3.5 scale to the panel width. And it stays on the same 1 foot on the y-axis, and is scaled up 3 feet on the z-axis to match that distance from the bottom of the panel to the window start, right? So, and we can just run this first, and then we can see the extent of this facade first, then describe what we're doing with the panel functions. So you see that same panel now going all around the building as we shown before in other scripts. Very simple. And now looking at the panel functions now that we didn't connect yet, we can see how we can change that panel and create these other panel variations. Okay, first thing is looking at this parameter, panel parameter input, that all we have 3 different panel functions. Each of them control one parameter of the panel. Okay, so in this case we have the height of the windows, one that we want to control. In this one we have the front bottom dimension that we have 3 now. Also we want to control that, and as well as that z-scale of that custom geometry object that we just looked at and described. So the key elements are the minimum and the max values that we input here. Those are basically whatever data that we input in the data list, it will be converted to these two, from this value to that value. And you see how the same happens for the front bottom and the scale C parameter. Okay, so basically what you can see what's going on here by just looking at this is like in this case, for instance, the smaller values will be mapped to 11, and the larger values will be mapped up to 0. So everything in between is gonna be in between those two values, and the same now from 3 the smaller values, and 14 the larger. Now looking at these two, you can see what's going on by looking at that once you have a 11 foot high window, you're gonna have a 3 foot value, the start from the panel bottom, right? And when you have 0 at the height of the actual no window, basically you're gonna have 14 is that from bottom value, which will be pretty much our entire panel, which is 14 foot high. And this basically follows the same as this from bottom, because that's exactly the same behavior and the same numbers that they need for these two parameters. So as far as we connect this random data we have here, just a start, just seeing how that random data can help just understand how this works. I just just typed a few numbers, and those numbers are going to go to our data list input. The last thing I'd like to talk about is that number of samples, number samples that input we have here. Basically, that says that we create this between these two. There are 10 values, 10 steps basically. So we can change that and create more in between values, which will create more panels basically. Now we can always look at this as a way to understand what's doing. It's in the output on this panel function. You see exactly what I'm describing. It's the data steps is included in the first output here. Now the data steps adjust to layers is basically of all these, which ones are used based on the data, but some of them maybe are not needed. So it tells you which one's going to be used, and then at the end, the entire data list how will be mapped to this step that we predefined. So as you change any of these values and this number of steps, this will update. So you can always keep an eye on this to see what's going on with those settings. Okay, so I'm gonna start with, like I said, a random number, a list of numbers there, and we just apply all these. We can put them all together in one data input and connect them there in design functions, and you'll see how now that changes as I was describing. Basically, the window heights and this element on the bottom, right? See how everything is scaling and doing what it's supposed to do. All right. So at that point, I think we what we can this may be key to understand how this data is mapped. So basically, it starts from the first element of this facade, and it goes around along the entire row, and once that all finishes, it starts over again. So that allows you to see how that is repeating around in different parts, right? Because it's basically going from row to row with this list of numbers until it completes all the panels around the building. So we can do something more visually appealing by just using, for example, this data mapper, a graph mapper that you will. In this case, I just started with a series of numbers between 1 and 50, and those are mapped to different parts of this graph as it goes through it. So that in that way, now I have more meaningful data that is creating something graphically at least, right? And you see how now those values has a little more interesting look, right? Now the thing we can change here is there's some steps that they are repeating, as you can see. So there's those 10 panels probably is not enough, so we can just throw, let's say, 30 and see how that gets a little more refined probably in that. There you go. So it's a little bit more there's no repeating panels because there's enough variations to cover all the options and all the the different variations that we are creating here with that data. All right, so that is very interesting. We can really go with that and show a range of different graphs showing us different things. And then let's see what else we can. I think there's one more that we can show you. Yeah, and that play with that allows you to get this more expressive use of these panels, as you see. All right. So, but now you understand more or less what how that data is used around the building. Now we could also work with not only with the data lists, but also with the data functions inputs that we have here. At this time we have one standard data function here, which is the panel data proximity. Okay, and there's also some custom ones that we can create, and I created for other purposes. But this one is kind of the more generic one that we can use in any facades or any scripts that with the idea of having these attractor objects basically. So I'll show you this, how this works now, and looking at this, how these objects can probably help us create different effects with the facade. Okay, in this case we have a box here that we're linking, and then we have this surface, this like elliptical object or sphere here, the form sphere in the other one, or these two actually are in one. Yes, these are the two objects in one, and there's a curve that is that element here and the other one. So we'll show you how this actually works together as we map this in the data functions. So each data function will go to each of those data functions P list, P because it's the panel data functions, and also instead of the layout data functions that we are, they are totally different in this case, right? So just connecting the three with those objects, the two objects that I was mentioning, there's a minimum distance and maximum distance that you want to play with. That means, it will start, everything at 0 will be detected, and then it will stop detecting those panels that are all farther away, from those objects at 8 feet, away from those objects basically. So the distance is more than 8 feet, it won't affect them basically. All right, so I connected that to the panel function. So now we have these elements affecting us in this facade. Okay, so we'll see the results. Now you see the effect here. Now I could also, to make this more obvious, I can apply this one value, which is the value min. Basically, you can apply a list with not only numbers but also with variables like value min and value max. So we'll create a list of one object, which will be the minimum of each of these. So that assures us that we have the same, the all valid combination of one of these minimums. So which is pretty much the what it looked like originally, right? So we'll have that minimum in each of them, but that one list, it's affected by now these data functions that will transform that based on the distances to our objects connected to it. So now you see how by the closest panels will have will go all the way to the maximum when it's 0 or close to 0 in this case, and it will gradually reduce its effect or to towards the minimum values when it's near 8, and after 8 they are left unmodified basically. So that allows you to play with this, very very much moving this around, and I'll just show you what this could this could look like if we select this guy. All right, there we go. I can just or scale it or move it around, but basically we'll update just to show you guys that it's really connected to that object, the effect. See how that now it's updated to that location. So it is a way to almost sculpt these panels based, let's say there's different programs that you want to have different opacity, for instance, right? Now you can change those numbers as well and play with it. Here also I have this curve that I was mentioning, and I can use a curve, not only solids, for these to affect the panel. So in this case I'll give it more range because it's only a thin element, so you need more range probably to have more effect, and this is the distance to the center of each panel that has to be between those two numbers. So see how by pumping up those values I really have quite some effect in a number of panels by using basically following those the distances between each panel and these different area points of the curve. Okay, so this gives you a little more kind of control on a way artistically, if you want, and how to manipulate these parameters of your panels. All right. So I'll leave that here in these settings, and we're gonna work now on the other script that we have on this side. Again, we're gonna first will be worth showing very quickly that we can see what other panels are being created. Okay, these are we said 30, so we have these panels, and those are again can be controlled by having this being any number, and you'll see how that is good to have also this display of panels and how they change in their resolution and show you exactly what panels you're obtaining. Okay, so that's something that you can always look at by using the panel inventory component, yeah, that will give you that extra information if you're interested. Finally, the other thing is that in case you didn't know yet, the skin generator has a kind of a log in the output here that shows you what's going on. For instance, at the top panel, the windows are fixed value, height, so it basically says that those panels tell you which panel, and it cannot fit the window, so it deleted that window. Okay, so this is a good thing just to know what's going on if you are interested in getting exact information. Also, when a panel is under a minimum value, which is a very small width or height, it will ignore it. So it tells you all these things as a log on each of the surfaces that are part of this skin generator. Okay. All right, that's good for now, and now we're gonna get going on the other side on this screen that we were talking about earlier. So this is at least for me, is the most fun of I guess SkinDesigner, because you can get very creative if you develop your custom or dynamic components, which is this guy. Let me show you how I did this. There's a few tricks or tips that we should follow first. First of all, we have this object here. This is a reference to my, that's just a reference to that surface that I trimmed in the scene. I trimmed it, it was an extrusion. I trimmed in a couple of places around it. So I, SkinDesigner or Skin Generator will not accept that as is, but it has to be somewhat of a consistent height. Okay. But this is how you do when a surface that has a trim like this one. So with these components, basically you get the untrim those surfaces and bring them together, and now you have an untrimmed surface here that works for the skin generator. Okay, now that surface will definitely then can be connected to our layer function as the modifier geometry, and that will basically, and I'll show you how this works to make a surface or facade that is actually regular in its edges, right? But before we go there, let's get the basics of how this works on the panel side first. So we have a simple panel. At this point, it's just, I'm gonna turn this on so we can see it. It's this guy here. I'm gonna turn off just to get a better view of them, all these other elements that we don't need. All right, so the way you have this kind of form that first of all is not a grid of panels. It's almost, it's a their location is in a checker box kind of pattern. Okay, so first of all, we have panel that at this point I'm not doing anything with it, it's just a wall with a name, and I think it's good to not show the actual dynamic or the custom geometry now, so you understand how this was mapped or arranged first in the facade. So I also have a void panel, which is basically that nothing is on. Even we hid that wall, hidden that wall. So the same dimensions as we normally do, but it's basically an empty panel. So if I turn this on right now, and this basically is mapping these two panels together and then shifting every row, okay, every floor. So when we turn this on, you understand how this actually looks like around the building, around this screen. See, you have this checkerbox kind of pattern of that building, of that solid panel and the void panel, which is what we need to create this, kind of more the hexagon, kind of honeycomb kind of text, pattern. Okay, so it's not like it's a grid and it's just one every, shifting in every floor in this shape. So we got that first, and then we once we have that, we can, we're gonna turn, unlock the solver for a second. We hide the we're gonna hide this wall so we don't see that, and we connect our custom component. I'm gonna turn off this also and unlock this. So I'll show you first, before we see the entire surface, how this panel looks like. Okay, now that's how this panel looks like, and it's all done. Basically, the only thing everything is in this dynamic geometry component. I uploaded a sample of one of those in the installation here. It's that guy here, and the controller of that one is there. Not always you need a controller. In this case, I have to, but in this case we don't need to control it with a specific, input on the panel function. It's just the panel that is generated. The geometry is what we need to be custom, and it's a simple Python input. You don't have to know how to do this, but it's just to show you how these panels are designed. It's just a few lines of code that does a few things. In this case, what I wanted is to be able to control independently these three kind of pairs or sections of the panels. So basically with a rotation from 0 to 90. All right. So that is all it's doing. This element. It's just creating a dynamic, geometry based on inputs that we like the panel rotations that can be provided at runtime when the facade is generated, and then some other panel properties that they are not changed, but that they have to be input, and has to do with different dimension thicknesses of things, that if you want to have that adjustable and makes sense to be that exposed. All right, so that is what is basically, that geometry is what is linked to our custom geometry component, and there's basically a placement that I want to make sure when we have this, if we turn disconnect this height panel, basically it has to be placed centered to that panel, right? So the having the wall kind of guides you, if I can see this, guides you where that should be placed. And this basically everything starts with, I did some math here. Okay, how many panels you want per floor? What is the floor to floor height? And with that we can get the width of the panels, and then with a little bit of math, how to center that geometry on that panel. That's all it is. As you see the relationship between the panel and this hexagon, kind of shaped panel. So all this, again, this script will be available for you guys in Hydra, like all the other ones. So you will be able just to run this on your own and play with it and do your own versions. But allows us here at least to change the sizes very quickly by specifying how many of these panels you want per floor, and in the the vertical, the height of the floor, right? So that two values will give you whatever you need in a project, for instance. And also, if you know any Python, you can actually play with also your panel and do your own versions. So the idea is to have a range of these ones on different type of panels, and people can plug in and play with in their scripts. All right, so now we're gonna leave this at 0, just because that's the default I want to have, just not rotation of any of those three area elements. And this is, like I said, connected here, and then we connected that to our custom systems, and everything else I think is explained so far. So Oh, the one thing we can that I think is the key before we get into this, or let's just show this first, right? I think that's a good step, and then I'll show you what is the next area I want to specify. It has to do with that trim surface I told you before. All right, that's our results. See, now it's the entire untrimmed surface that is being mapped with this honeycomb kind of hexagon shaped panel. All right, so how we get this shape to match this trim object that is a different element, right? It's a different shape. These guys then, because basically we did this with a layout function here that I explained earlier very quickly. So having these two, we said this checkered pattern, and you see here in my skin generator, I'm pointing to panel number 2 as the default. Basically, the default is the void. Okay, so at this point, everything is not dictated by the default because everything is dictated now by our layout function, this pattern. But if I make this trimmed surface, and I want to show you that object again, just to make sure you understand the shape, how it looks like. Let me just turn this off. That's the trimmed surface. So if that is now the one element that constrains the pattern to. So this only will happen, as you learned in the other tutorials. This pattern will only happen on this area. Everything else will be the void panel, what is outside of this. So by adding that just trim surface there, which we can add any type of surface there, you see how now our facade only is limited to that trimmed area. So the secret is having a void panel as the default. Here is number 2, our void panel, and then limiting that with a trim surface to the areas that we want the panels to happen. Okay, but having always an untrimmed version is necessary for the skin generator here as a facade element. Okay, so between these two things you can really get any shape of any shape of facade. It's still vertical, and it's one of the requirements that we have right now. Now you can get also more advanced with panel functions to do more, not even kind of vertical surfaces, and it will be even more sculpt surfaces. But for now, I think keeping it not too complex and step by step going through the different things. This is already, something that is a little bit different than what we've done before. Okay, so next step is using the panel functions, which is the main kind of topic in this tutorial. So the panel functions it's one panel function really at this point, and we are using everything we have done so far, which is our panel functions with this one value, which is the minimum, and we have our minimum maximum at 10 or 90. So it goes from 10 to 90, which is the rotation basically. Now you see how the parameter is basically dynamic geometry parameters. So this is on this again our provided different parameters for panel functions, and this is for all kind of things like scale, like we used in the other example, placement. But then the dynamic, this is specific for dynamic geometry, which is what this parameter, this component has. Basically what it's doing is sending to this component those values, and this component is set up in a way that it knows that value that we'll receive has to do with the rotations. Okay, so we're gonna have one value, and when these components, dynamic components, receive one value, we'll apply to any, instead of having only to one of those 3 elements, it will apply to the 3 of them the same value. Okay, this is just to keep it simple, and basically it will have to do with proximity. This is another, the same as the other one, panel data proximity, which is a tractor objects that we already placed, and you see how that are the two objects that will dictate, you know, the effect on how much they open. Basically, those areas will be more open based on the on the proximity to these objects. Okay, this one is a curve. You see again, it's hard to see maybe, but there's a curve. Yeah, that element there. It's just a curve that goes through everything. Just to show you also that you can use curves, not only solids. Okay. All right. So we have all that. Again, this is going from those two values. There's a 10. You know, the samples are 10, so it will be 10 different panels between these two values, and you know, depending on how close are these two, you know, these objects to the panels. All right, so I think we are good to go and plug this design function to our. Oh, we're gonna add it right here because we already have a layout function that is part of the same input. Okay, so we're gonna just connect that. We'll send them all together. All right, there we go. So see how that now has a lot more variation. I mean, these panels being rotated from 90 degrees to be completely open here to more, you know, closer, you know, more close until they are, you know, nothing that has changed on these guys here. So because the minimum is 10 here, even the ones that are not affected, it has some shape to it, which is 10 degrees that is being open. All right, it's not completely flat. That's just purpose, you know, the intention to have some at least shape all the panels. But you see how these objects are doing all the work here. These attractor objects, right? There's these two guys here, and then the curve that I was saying going between. Now, if I change this to, I don't know, 10, would be a lot less. The effect will be a lot less dramatic, right? So it gets reduced. You see how now it's a lot more defined, the objects, how, you know, those elements are being affected. So you can definitely play with this to take, you know, get the effect you want. I prefer, you know, something that is more obvious and you know, more just go through and more of the surface, right? So that gives you a little bit of that idea. Now I think there's one thing that I think, yeah, there's one little thing I want to show you that it may be, you know, just another little element that, you know, you can use. Let's say you want to avoid some areas to be affected by these panel functions, right? So let's say we copy this. I guess I want to grab everything, so let me do this again. Let's see if I can grab them all. There we go. So we're gonna call this a different name. Just call it like static. So that's something that probably means it's not gonna be affected by the panel functions. So the only thing, we need to get our custom geometry here to be different than this one. Otherwise, it will still be affected because it's the same. Now this output here, the brep output, is that same. If we can see it here, is that geometry basically that is, you know, unchanged. And this is a static element now. It's not part of this this input here that is, you know, it has actually, it's a piece of code, you know, it's a dynamic geometry instance. This is just breps at this point. So we can connect those breps to our geometry here instead of the actual dynamic geometry element. That will basically say that that object is not changed. That object has no, you know, effect on any data, any, you know, parameters that will be sent to. You won't detect that dynamic geometry, so it won't do anything. So if we bring this panel to our list of panels, we connect that in panel 3. All right, so that is one thing. Now we don't want that to happen. Still, this has to be mapped in a way that makes sense, according to this checkerboard box, you know, checkerboard pattern or checker pattern. Sorry. So we can copy this, another layout function here, and we can, instead of having this guy, we're gonna have, it's gonna bring this one object that I interested on. Let's see if I can find, which is this element here, this surface. So I'm gonna just copy the one surf, this input. Hopefully I can select this guy. See, we get lucky here. There we go. All right, I think it's that guy. Here you go. So now we have that, and then we link that to our modifier geometry here. So basically now we have, instead of the 1 and 2, we're gonna have 3 and 2. So still we have this checker pattern, but instead of having the panel, the dynamic component panel, which is the panel number 2, we're gonna have this panel number 3 that we created that doesn't have that dynamic component. So in that way, and I'm gonna turn off this so it doesn't get on the way. Just gonna turn on these objects that they seem to be, there we go, they're off, there you go. So basically now we have this band of these layouts, and now we need to connect this also, this layout function here in between. Also to tell you that, you know, if you have a number of layout functions overlapping, like this one, it takes care of the entire surface. You see in this entire area, right? And this one is only a portion, but it's on top of this one. So the order of these layout functions is important. I hope that's clear, but you know, this one is definitely going through the entire, you know, it's gonna map this entire surface. And now this goes after this one, this second one, and will actually override that piece with the panel that we are providing here, which is that new panel that we created, the 3. All right, so this is something you could do as layers, basically, you know, and the order is very important. So first you do the ones that they are the bigger areas, and then the things that you want to override should come later. The panel functions can come any time in that, but still connected to the same group. There's no need to be any order on the panel functions. So now if we look at this and turn this on, hopefully everything works. And I think we should be done. This is a long tutorial, and I apologize for that. But you see how some of these panels are being unaffected here, right? And this, because it's a small band there, you see some areas are less obvious. But you see how actually that stays on the flat, which is, you know, basically is our flat version that we linked here. This is our it's not even rotated even in any degrees, right? So that is a way to create kind of this combination of panels that they are changed, but then some of them are not affected, by having a copy of those panels that have a different name. Or they don't have, basically, by having a different name is actually one good thing to do. Of course, it cannot be the same name. But the panel functions as well, you know, because it doesn't have a dynamic component. But let's say you have a dynamic component or dynamic geometry on this one too. You decide, if you want, you decide not to be affected by using the panel names filter, which in this case is only the one we have originally. So you could have the same panel, you know, geometry and the same kind of, you know, all the same, copying exactly the same panel, changing the name, and then map them in the, you know, different parts of the facade, and then you can decide what parts of, or what panels these panel functions will be directed to, okay, by applying the name as a panel filter. All right, and I think that's enough for today. It's a lot of, you know, work with panel functions, and I think, you know, we pushed it a little bit with the dynamic geometry, which really creates, you know, I feel pretty interesting and promising kind of configurations of facade systems that I think can not be just this one, but be anything we want. And I will be providing, as we develop more examples, new versions and new types of panels. This is something that I just came up, but it's you know, it's very straightforward to add more of them and have different variations. All right. So hopefully you like this tutorial. I will save this, as I said, on the Hydra website. Hopefully you can just turn on the skin generator and see this and start playing with the changing settings and playing with your panels, if you will, to do other things with it. Hopefully if you have any questions, issues as well, always use the Grasshopper website to direct them. I'll be happy to respond those, and look forward to any input on your side, and hopefully you have fun. Thank you.